Everybody. My name is Steve Edwards, as the slide says, and actually it looks pretty good up there. That's one of our lights, and I'm here to talk about lighting. Essentially, the question I'm posing to you in the room, and also to, I guess, the wider commercial world and domestic world is has LED lighting come of age? So I just wanted to take you through a little bit of a history and a storybook through to where I think we are today. And I'll pose that question at the end and see what you guys think. So, LEDs. Essentially, it's light emitted from a silicon material or a silicon carbide. So the first person who found that light came out of a silicon carbide, a guy called Henry Round, who was working with Marconi back in 1907. He thought it was great, nobody else did, so nothing happened with that until 1939, when the first patent was issued to develop some form of light-emitting diode. So the first practical application of LEDs actually took quite a few more decades before it actually became relevant as a commercial application. And this was usually as indicator lights. So right from the 1960s right the way through the 70s into the 80s, LEDs were predominantly used for indicator lights on PCs and televisions and that sort of thing. In 1994, a company called Nichia, who's a current chip manufacturer, they found that they could actually create a very high brightness blue LED. And that's the basic principle on which pretty much all white LEDs has now been developed. So that was back in 1994. And in 1995, lo and behold, they found out that they could actually turn the blue LED into a white LED by adding layers of phosphor on top of the LED itself. So it moved the spectrum of light from blue into white. And since that point, we've actually seen an exponential rise in the quality of light that comes from LED chips, the brightness of those LED chips and the stability of that light coming off that. So there's been an exponential rise over the last few years since 1995. And I'll go through that in a minute. So just fundamentally, what do LEDs actually comprise of? Well, you have the light emitting diode. So that's the bit of silicon that actually emits the light itself. You then also have what they call an extra low voltage driver. So all LEDs run off a very low voltage, like 1 or 2, 3 volts sort of thing. And you have to take the 240 volts that's coming through the grid and step it down to a very low voltage, what they call an extra low voltage. That's done through a driver or a transformer, for want of a better word. So the other thing you have to worry about with LEDs is how do you actually make that light work best? And one of the most important things a lot of manufacturers forget about is the optimal light diffusion. So how do you turn what essentially is a point source of light from a very small chip that's emitting a bright light, how do you spread that light out and make it diffuse nicely into a room? So the optics are quite an important aspect of the whole process. And then also, LEDs generate heat. They're almost as much of a heat generator as a normal incandescent light bulb. So there's an awful lot of heat comes from an LED when you're in the process of manufacturing light from silicon. If you don't take that heat away, then the phosphor will burn off the LED. The LED will move back from white back into its natural blue state. The driver will overheat, the components in the driver will go pop, and the thing will stop working. And quite often, for example, if you're walking up King's Cross Station in London, if you go up the escalators and you look up and all their LED bulbs they put in about 18 months ago, some of them have started to go blue and some have started to completely fail. And that's because they've used cheap components, cheap product, cheap design, and poor heat dissipation fundamentally is a real problem there. So each of those elements above are a weak point, and unless you address each of those elements as a weak point and find out the best way of making sure you have the quality in your unit, you will end up with a unit that will fail relatively quickly and not give the sort of light you're looking for. So the quality of each element is key to a robust product. But one of the other limiting factors for LED in the past has been the high cost. So invariably, cost of LED has been a prohibitive factor. So when you're looking at a project or you wanting to design LED into a commercial building, if the cost of it is too high, is that me buzzing? Probably. If the cost of it is too high, then you'll end up not being adopted onto that project. So you'll end up with a situation where LED might tick all the boxes in terms of light dissipation, lighting a room, energy saving, but commercially it fails. So you have to get the balance of commercial right in the whole process as well. So the development of LED, I said earlier there's been an exponential improvement in LED over time. So back in 2010, not so long ago, just over 2 years ago, we were achieving 65 lumens a watt from white LEDs. 2011, that leapt to 90 lumens a watt. Last year, we were toying around 110 lumens a watt as an output. So this is how much light you get for every watt of power consumed. In 2013, Cree have actually just launched a chip that will emit 186 lumens per watt. So a significant jump in just 3 years, or 2.5 years, a significant jump, threefold increase in the amount of light that is emitted from LEDs. So the process of manufacturing LED determines how good that chip is. So they'll actually, when they manufacture an LED, they'll actually what they call bin it. They'll put it into different bins, much like they do with bottles of wine. So the better quality chips are the ones that will have a much more stable light output compared to its neighbour. So you'll have a long line of LEDs that all emit a similar level of light, similar coloration of light. Those will be considered high quality and go into the high quality bin. The lower end of the scale, you get chips that are sort of vary in colour, so your lights will look slightly different in the coloration, and those are the cheaper end of the scale. So binning of LEDs is quite important, but in the whole essence of LED lighting is, at the end of the day, you're putting a light in the ceiling. Nobody really matters what you're looking at up there. They're worried about what's happening down here and how you're lighting your room. And if you don't get the optics right, if you don't get that light diffusion and that light dissipation right, it doesn't matter what you're putting up there, this won't look right. You have to get the right level of light, the right balance of light, the right distribution of light. So the optics are quite important in the whole process. How does that compare to conventional lighting? Well, we're now at a position where we're almost as efficient as a low sodium vapor lamp, which is the horrible yellow sontees you see in street lighting, which are gradually being phased out over time. Fundamentally, every single other conventional light source has a poorer efficiency rating. It generates less light per watt of consumption. So LED is by far and away the most efficient light source available to us now. So let me just go on some of the other weak points. The driver, the extra low voltage driver that you need in order to turn your 240 volts into a usable voltage, that will invariably fail before the LEDs do. So if you're using cheap componentry in that, and you're not dissipating the heat away from the drivers through a proper heat dissipation system, you compromise the life of that driver even more. You have to make sure that whatever you're doing, if someone is saying use an LED light, it's not just the bit that emits the light, it's not just the diode, it's the whole luminaire, including the driver. And if the driver's not of a good quality, the lifetime of that unit will be compromised. So you have to take that into consideration. Heat dissipation, vital. You don't take it away, the LEDs will quickly move back to their blue state because the fossil will burn off it. The poor quality heat sinks, if the material composition of the heat sinks is not of a high grade to take that heat away, then again you'll get heat build-up. The design of the LED itself, in terms of maximising the surface area, in terms of the heat dissipation device, the heat sink, if you don't maximise the surface area, your heat again won't be dissipated quickly enough. So it will compromise the life of the unit because fundamentally your fossil will burn away, you'll go back to blue, and you'll end up with a driver that fails. Lastly, again, the commercial is important. You've got to balance that quality. You've got to make sure you have a good quality light, long life, but with a good price. Everybody can issue a Rolls Royce, but not everybody drives a Rolls Royce. So it's possible to go and get a Rolls Royce, but commercially it's not viable. If you go and get an Audi or a BMW, you're getting into the right ballpark. You're getting a very good quality product which has got a good commercial price on it. And that's the balance you've got to try and achieve as an LED manufacturer or distributor of LEDs. I just want to quickly just show you how this equates in real terms. So this here is our favourite good old-fashioned 4-tube fluorescent modular fitting you see in many offices throughout the UK. The green and orange image on the top is an overhead plan view of a simple office with 4 lights in it. The green is showing the distribution of light, and you're achieving around about 3. The great scale at the bottom is your lux level, the amount of lux you're achieving in the room. So the green is saying you're above 300 lux on average across that room, and you have, in an office environment with PC, you have to achieve around about 300 lux as a minimum. That's our good old 4-tube modular fluorescent fitting. Comes in around about 40 to 60 pounds, generating on average in this space with four tubes offer an 88 watt consumption, about 342 lux. Move to the more efficient T5 fluorescents, and suddenly you're increasing a better distribution of lights. The distribution of light is much better. If you look at the middle picture, you can see actually that the light on the walls is much higher up the walls, so you're getting a much better distribution of light across the space. You're lighting the room much better. You're consuming about 86 watts there, generating about 374 lux, and you usually can buy those sort of modular fittings for between 60 and 100 pounds. Last year we were running with an LED light panel. Now this LED light panel achieved a very, very similar result within a space as a T5 modular fitting. So we're achieving the same sort of lux level, very, very good distribution of light. In fact, we're achieving a greater light on the walls because the distribution of the light through is a micropyramidal diffuser. So going back to the optics, it's a very, very good optic distributor of the light from the source from this panel. We're achieving a much higher illumination on the walls. Last year we were selling that for £165, and it comes as a dimmable unit as a standard. We've now evolved that to a 41 watts and come down 1 watt. We've increased the light output, so we're actually achieving a better light within the space. And we're now down to £120. So we're balancing this quality, the consistency of light dissipation, and getting the commercial right. We're just about to bring out a panel which has now dropped the power consumption considerably. There's a compromise in that you've tailed off a little bit on the light output, but we're still better than a 4-tube fluorescent. We're almost as good as a T5 fluorescent. We're achieving the right amount of light within the space, but we're saving over 60% of the power that you would normally consume within that office, and that's for £85. So commercially, we have the quality right, the light distribution right, and the commercial right. And this is why evolution of LED has seen such a significant change, because you're getting the good quality of light, you're getting the commercial right, and it's now becoming a viable option on projects. We've just brought out a new panel light as well, which allows you to light sideways from it to illuminate the ceiling. So for those lighting designers in the room, and I'm sure there are not many of you who are lighting designers, but you have to try and achieve some illumination onto the ceiling when you're lighting a space. Used to be around about 30%, now they're actually specifying a certain lux level on the ceiling. This lighting panel we've just designed allows you to do that directly from the light luminaire itself, so it contributes towards that process of lighting the ceiling. So in conclusion then really, we now are in a position where LED luminaires are producing a high quality light output. They have a good lumen output, a good distribution of light, and a very low what they call unified glare ratio, UGR, which means that when you have that light within a space, you're not getting glare off your computer screens and off your monitors and so on. We now have a genuine long life associated with it because we're tackling the issue of quality of drivers and the extra low voltage drivers as well as the componentry within it. We're seeing significant energy savings from these products, and we have a competitive commercial pricing point. But for us, the missing link is it's not just about light, it's how you control those lights. If you can wrap an intelligent form of control around it, and the last speaker was talking about controls and the one before that. So if you actually look at a whole energy solution, you wrap an intelligent control system around LED lighting, you can really maximise those savings. And we're working with a company called Open Technology who operate an intelligent system that links into BMS systems within buildings to do this. With that, we can achieve an additional 20 to 30% saving on top of the saving you get from the LED lighting. So my question back to the audience is, has LED lighting come of age? And some of the people we're working with think it has. Thank you.